The effects of light pollutants wavelengths on memory and locomotion in the Drosophila melanogaster. Light pollution, also known as photopollution, luminous pollution, or sky glow, is excessive, misdirected, or obtrusive artificial light in the night sky. This causes the night sky to become brighter. This map of the Earth was taken by a satellite. It shows the amount of light that is directed into the sky. More dense populations have a greater amount of light pollution. Animals such as bats and turtles are affected by light pollution. This is because their circadian rhythms are thrown off by light pollution. Turtles and bats are not the only animals affected by light pollution. There are many other animals that are affected by light pollution, and they can even die from the consequences. The wake-sleep rhythm of humans is synchronized by the intensity and spectral composition of light. Light pollution can disrupt our circadian rhythms and cause many human health problems. Such problems can be sleep deprivation and even cancer. This is a picture of the Drosophila melanogaster. This organism is going to be used in the experiment because of its small size, short lifespan, the close similarities to the human genome, and their rapid reproduction. This picture compares the circadian rhythms of the Drosophila melanogaster and humans. They have a similar circadian rhythm. Many basic biological, physiological, and neurological properties are conserved between mammals and the Drosophila melanogaster. This slide shows the visible light spectrum and their wavelengths. The red light has the largest wavelength, making it the least powerful and the least intense. Then, from left to right, the wavelengths become shorter, making the light more intense. The violet light is all the way to the right of the spectrum, making it the most intense with the shortest wavelength. The National Dark Sky Association put out this graph. The x-axis is the wavelength in nanometers, and the y-axis is the relative sensitivity. They found that light pollution has an effect on the circadian rhythm. This is a photo that was put up by Cinzano 2001. It shows light pollution in America over the past 60 years. The map shows that in the 1950s, little light pollution was present. Then, over the decades, light pollution was becoming greater and greater. Now they predicted that in 2025, areas like New York City will be 81 times the normal level of light. This will cause stars and constellations like the Big Dipper not to be present in the night sky. In the United States, 6% of the electricity produced is used for outdoor lighting. Of that, 30% of the light is wasted as light pollution. This wastes about $10.6 billion a year. Streetlights are one of the worst structures for light pollution. In the diagram, it shows different street lamps. The lamp all the way to the left shines light in all directions. This causes the most light pollution. Then from left to right, the light becomes more refined to a certain spot and causes less light pollution. The top shows what the night sky may appear like with the different lights. In these diagrams created by Lee 2013, they show his perception of the ideal streetlight. The diagram on the top shows the normal streetlight all the way to the left. He then created a diagram with the normal streetlight, which is the middle picture, and he created a diagram with his perception of the ideal streetlight, which is the right picture. He then stated that the difference with his light and the regular street lamps is that his light is encased in a reflexive box which can concentrate all the light to the ground, while the normal light can shine the light into the air and in all directions. The diagram on the bottom shows how Lee thinks that a light who is perpendicular to the ground gives off less light pollution, which is the right picture, than having the light at an angle with the ground, which is the left picture. In the experiment conducted by Fauci 2011, he tested different lights in their relation to melatonin suppression and other circadian rhythms. The lamps that he used were high-powered sodium light, low-powered sodium light, metal halide, natural white LED, and an incandescent bulb. After his experiment was conducted, he found that the low sodium powered light gave off the least amount of light pollution. The purpose of the experiment is to find which wavelength of light will least affect the bodily functions in the Drosophila melanogaster. Based on the studies of Stevens 2009 and Selzer 1981, it is predicted that the blue light will have the most effect on locomotion and memory in the Drosophila melanogaster. For this experiment, there are going to be different lights being used for two different. These are the lights that will be used in the experiment. There is a control clear LED light, a red LED light, a blue LED light, a green LED light, an orange LED light, and a yellow LED light will all be used as variables. Then there are the two procedures. The first procedure is the locomotion procedure. To prepare for this procedure, prepare the climbing apparatus for each group such that two polystyrene vials are vertically joined by tape facing each other. For the lower vial, measure a vertical distance of 8 centimeters above the bottom surface and mark each vial by drawing a circle around the entire circumference. Transfer a group of 10 flies into the lower vial carefully, preventing the escape of any fly. Allow the flies to acclimatize to the new setting before 1 minute, then conduct the assay. Gently tap the flies down to the bottom of the vial and mark how many can climb above the 8 centimeter mark in 10 seconds. Repeat this assay for the same group 10 times. Allow for a 1 minute resting period between each trial. Record the number of flies that pass the 8 centimeter mark as a percentage of total flies. The second procedure is to test memory. To test memory, first train the flies to associate the light with the aversive stimuli. Then, to prepare the T-maze, place two 15 milliliter plastic centrifuge tubes and cut them at the 2 millimeter mark from the bottom with a manual saw. Connect the connector adapters at each end and seal the connection with parafilm. Connect one tube with the light source, and this tube will be the lighted chamber. Wrap the other tube in aluminum foil to serve as the dark chamber. Add 180 milliliters of quinine solution to the filter paper and place in the lighted chamber. Assemble the T-maze by first screwing the lighted and dark chambers onto each side of the center column with the trapdoor closed. Test each fly 5 times, and the fly should pass by recognizing the stimuli at least 3 times. The data will be analyzed by means plus or minus the standard deviation, and the statistical analysis is a one-way ANOVA post-hoc Scheffé test with a significance of less than 0.05. The Drosophila melanogaster Drosophila vials, disposable centrifuge tubes, parafilm, aluminum foil will be obtained from Carolina. Mini deep dome light fixture and incandescent white bulb will also be obtained from Carolina. All of the LED colored bulbs will be obtained from Bulb America. Works cited.